स्वागत है आप सभी का हमारे इस YouTube चैनल में, जहां पे आज हम देखने वाले हैं साइलैब पार्ट 2। अगर आज से पहले आपने साइलैब का इंस्टॉलेशन और बेसिक पार्ट 1 नहीं देखा है तो प्लीज उसका वीडियो आप देख लीजिए। Outline of this presentation is: first we discuss basic command, then mathematical operator, mathematical trigonometry function, then mathematical other function, predefined mathematical variable, comparison operator, complex number elementary function, data types, function with generate matrices, and accessing the elements of a matrix with accessing the matrix with a colon operator, element wise operation, then defining a function, and plotting and reference. So let's first discuss basic command. So let's first see basic command. The line which begins with 2/ is considered by a Scilab as a comment. Boolean variable can store true or false value. True is written with a %t or %t, and false is written with %f or capital %F. And string can be stored in variable provided that they are delimited by double quotas. And wait function is used to exit from Scilab. So let's see the basic command in the Scilab console window. So let's see, when you press x equal to 1, it execute x equal to 1, and that can be seen also is in the variable browser with the x name, value, type, visibility, and memory. Then clear is used to clear variable browser. When we press clear, then we can see now variable browser is clear. Then CLC, that is used to clear the console window. That message is, are you sure want to clear the console window? Then when you click do not show this message again, then it will not show again in the future. So click this box and say yes. So now you can see the Windows console window is clear. So now let's say x equal to 1 once again, and when you put semicolon here, then that is not executed. So क्या होगा कि लाइन रन तो हो जाएगा लेकिन console window पे उसका execution नहीं देखने को मिलेगा. So that is executed, you can see in the variable browser also. Okay, now say add equal to x plus 2. So that is indicated with the addition. Now add equal to 3. Then sub equal to subtraction, or sub equal to x minus 1. And when I put semicolon here and after the particular line, then this line execution is not shown in the console window. So sub is there, and similarly you can see in the variable browser also. Okay, so x minus 1, so x equal to 1, so 1 minus 1 equal to 0. Then multiplication, so multiplication equal to x into 2. So 1 into 2 is a 2, so 2 is the answer. Okay, then let's say another variable y equal to 2 or 3, whatever, 2. Then for division, let's say right division. So right division, that means x divided by y, x divided by y. So 1 divided by 2, that is answer of this particular right division. So right division is 0.5, 1 divided by 2, so 0.5 is answer. And when you use left division, so left division, that can, let's say variable left division, that is equal to, then it is indicated with x left division y. So that is 2, because now y divided by x, so y is 2 and x equal to 1, so that is a 2 is the answer. Similarly power is used, so power, that is equal to x raised to 2, so 1 raised to 2 is equal to 1, so 1 is the answer. Then you can also use a power like this, power, that is equal to x 2 times multiplication with 2, so the answer is same, 1 raised to 2 is a same. And I is used for conjugate, like I, if I simply type I, then simply 0 plus I is there, or okay, percentage I, so percentage I, so it gives me 0 plus I. Okay, so that is from the basic one. Let's see another part of the presentation. So this is the mathematical operation that we already see: addition, subtraction, multiplication, right division, that is x divided by y, and left division, that is x inverse y, that is a y divided by x. Power, that can give x raised to y, and power, that is same as x raised to y, and transpose or conjugate, that we'll discuss later. Then mathematical trigonometric function. So these are the different mathematical trigonometric function that will be done with the help of sine, like cosine, a cos, hyperbolic, then sine, a cos, hyperbolic, then tan. So all different kind of chord, all the different kind of trigonometric function is done with the help of Scilab. Let's see one or two types of mathematical trigonometric function with the help of Scilab. We clear this and CLC. Okay, so all the things are clear. Okay. Now say a equal to cos percentage pi. Okay, so it will show you the cos pi value. Similarly, b equal to sine percentage pi. So it show you the sine pi value. When we press a square plus b square, so a square plus b square in this case is cos square theta plus sine square theta. So that is equal to 1. So let's see with the help of Scilab. So a power of 2 plus b power of 2, and it is 1. So that can be seen in this particular example. So similarly, we can apply all the trigonometric function in the Scilab. So let's move to the next part of the presentation. So exponential, exponential m, logarithmic, then maximum, minimum, square root. This is the different mathematical function that can be also done with the help of Scilab. So let's do the operation of other function in the Scilab. Clear the variable window and then clear the constant window. Okay, so now let's say a equal to exponential of 0. So exponential of 0 is 1. The answer is 1. We can also check exponential 1 value. So b equal to exponential of 1. So that is around 2.71. Okay, so similarly we can also check log value, like log 10 is 10. So that is answer also 1. So similarly we can check other function of the mathematical with the help of Scilab. Let's move to the next part. Then predefined mathematical variable. So imaginary number I, percentage Euler constant, and percent pi, the mathematical constant that can be also done with the help of Scilab. We already seen percentage I and percentage pi use of this particular command in the Scilab. Then next is a comparison operator. So A and B logical, A or B logical or logical not. True if the two expressions are equal, A equal to B, then A not equal to B, or A not equal to B. That is a true if the two expressions are different, then A less than B. True if A is lower than B, A greater than B, A less than equal to B, A greater than equal to B. So this is the kind of operation in the comparison operator. So let's try to check different kind of comparison operator in the Scilab. The variable browser, and similarly clear the command console window. So we already know that percent 2 is there. So this is the Boolean variable. You can also check. So this is the, you can see answer is a Boolean. Okay. Similarly, you can also check for the percentage f. The percentage f is also Boolean. Okay. So now clear. We'll see. Then like say a equal to 0 equal to 1. So 0 is equal to 1. Is it true or false? Is it a false? So that's why his answer is false. You can check in the Boolean variable, we get the answer as false because 0 is not equal to 1. And if you see that here 1 equal to 1, then answer is true because 1 equal to 2, that is a correct one. Okay, now let's say first clear this CLC, then okay, we a equal to 001, then b equal to true condition. So b is a true and f a is a false. So now what happened when we give the a and B. So A is false, B is true. So answer is in AND false and true. Answer is false. 0, 1. So in AND operation you get the 0. So false and true, you get the answer as false. When we do the ORing operation, A or B, so in this case it is a true because 0, 1, 0 or 1. So that is answer is true or 1. So similarly you can check for the another one like and not A. So for here A is false. So now not A is true. Okay, so not A is true. When you check A equal to B, that is also false because A is false and B is true. So false equal to not true. That's the answer is false. Then A not equal to B, yes, that is a true because A is false and B equal to true. So A does not equal to B. So answer is true. When you click like this, A not equal to B, it is the same kind of operation. You get the answer as true. Okay, so you can check for the different like another comparison operator. It's like A equal to, first clear this CLC. Okay, so now say let A equal to 1 and B equal to 2. Okay, so let's check condition A less than B. A is 1, B is 2. A less than B, you get the answer true because A is 1, B is 2. So A is less than B. When you type A greater than B for the same condition, you get the answer false because A is less than B, not greater than B. Then you can also check A less than equal to B. Answer is true because A is 1, B is 2. So A is less than equal to B. And similarly, you can check A greater than equal to B. You get the answer false because A is not greater than or equal to B. Okay, so this is the comparison operator from the Scilab. Hope you understand all the comparison operator in the particular module. Let's do the next part. Complex number elementary function. So real, imaginary, and multiplication is real. That can be checked with the help of Scilab. So let's do this kind of task in the Scilab module. First, clear and CLC. Okay, then say percentage I. So this is the 0 plus I. Okay, and you get I percentage I square. So what is I square value? I square is a -1. So you get -1 plus 0I. Okay. Let's try it on with another example. A is equal to 1 plus 2 multiply percentage I. So there is nothing but A equal to 1 plus 2I. So here real part is 1, imaginary part is 2. So that can also check with the help of I, imaginary part of A, that is imaginary part is 2, okay, and real part is 1. So is real A. Okay, so this is the real part only. If is real, A is real, so A got both value, real and imaginary. That's why answer is false. If A is equal to only 3 and now you put this condition is real is A, then you get the true condition because now only A is equal to 3, no imaginary part is there in the A. Okay, so this is the use of imaginary or complex number in the Scilab. Now let's move to the next part, data type. So an n bit signed integer take its value from the range -2 raised to n minus 1 to 2 raised to n minus 1 minus 1. And n bit unsigned integer takes its value from the range of 0 to 2 raised to n minus 1. Like this is the integer 8, integer 16, integer 32, unit 8, unit 16, and unit 32. This is the value for the different condition, like if y is equal to integer 8 of x, then 8-bit signed integer in -2 raised to 7 to 2 raised to 7 minus 1, that is value around -128 to 127, and similarly for the different condition. Then create a matrix of real value. So square bracket mark the beginning and end of the matrix. then comma separate the value in different columns, and semicolon separate the value of different rows. Okay, let's do this kind of operation in the Scilab. First clear and CLC. So let's create A is equal to 1, 2, 3. So only 1 by 3, 1 row, 3 column is created with the help of A equal to 1, 2, 3. Similarly, we can also create B equal to 4, 5, 6. So 1 row, 3 column, 4, 5, 6 is created. Now let's say 1, 2, 3 and semicolon 4, 5, 6. So now in this case 2 row 1, 2, 3 is a semicolon is there. That is the meaning of you have to go for the next row. So 4, 5, 6, 2 row and 3 column is created. If I want to create a different kind of matrix like D is equal to I of 3 comma 3. So it indicates the 3 by 3 matrix with the triangle with this diagonal value is 1. Then similarly you can also create ones like E equal to ones 3 comma 3. So 3 by 3 matrix with the value of 1, all the values are 1 is created. Similarly you can also create 0 value like F equal to zeros 3 comma 3. So all the values are 0 in the 3 by 3 matrix. Okay, so first clear these and clear the window. So similarly, you can also create the random matrix like RA and D 3 comma 3. So it generates a 3 by 3 matrix, the random value. If you if once again repeat the same command, the answer is different. Like we execute the same command, answer is different from the earlier one because this is the random value. Okay, so let's move to the next part. Function will generate matrices. So I line space 1, 0 test matrix, then random number generator that already we discussed. Then accessing the element of matrix. So the whole matrix with the A syntax. Then element by element with the A of I comma j in syntax. Then a range of index value with the colon operator. Okay, so let's do this kind of operation. Then accessing to matrix with a colon operator, that the wall matrix with the colon operator, the element at row from I to j at column k, then the element at row I column from j to k, the row I all the column, the all row with the j column. So that can be discussed or that can be seen in the Scilab platform. So let's do the task in the Scilab platform. Clear CLC. Okay, so first create one matrix A equal to 1, 2, 3 semicolon 4, 5, 6. So 2 by 3 matrix is created. We can also check the size of the matrix A. The size of matrix is row 2 column 3. Now let's another create one variable B that is equal to 1 to 10. So here use of colon operator. So it gives the value of B from 1 to 10 with the increment of 1. So you can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can also change here like this C equal to 1 to 10. But here now increment by order of 2. So when you click this, enter this, then you can see 1 plus 2, 3 plus 2, 5 plus 2, 7 plus 2, 9. So up to 9 is there because 9 plus 2 is 11. But you have to stop up to 10. So this is the use of the colon operator. We can also do the reverse kind of thing like decrement operation. So D equal to 10 colon minus 2 colon 1. So you can see D equal to 10, 8, 6, 4 and 2. Okay. So this is the use of colon operator. Okay. So now create like once again we create one matrix with the help of square bracket. So 1, 2, 3 semicolon 4, 5, 6 colon semicolon 7, 8, 9. So here 3 by 3 matrix is created. Now if I want to access first row and second column elements, so A of first row, there is a first row and second column element. So A 1 comma 2. So there is the element of 2, 1 first row, second column. So you get the answer 2. If I want to get all the elements, so just put A of all the row and all the column. So you get all the matrices value. Just I clear the console window. I require the variable of A. Now if I want to get only two columns from the specific variable, so A of all the row, but column only from 1 to 2. So you get all the row. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. But you get the all the row, but column only 1, 2. So first column and second column is there. Now another operation is only you want to access first two row, but all the column. Then in this case, first two row 1, 2, 3, 4, 5, 6 with the all the column is this place. Similarly, for the only first row, but all the column, in this case only 1, 2, 3 is there. Okay. Then if you want only column and first row, then A of all the row with only first column, then you get the 1 for 7. Okay, so this is the kind of operation we can done with the help of accessing the element of matrix. Okay, now I just clear the variable and clear the command console window. Then if I want to create once 3 comma 3, then it create a 1 by 1 matrix. Then B is equal to say 3 multiply by of multiplication of ones 3 comma 3. So now 3 is multiplied with each of the element. Okay, so 3 by 3 matrix with value, each value is 3 is there. Now if you see C equal to A multiplied by B, then you get the 9 because A is now multiplied by B. So A multiplied by B, there is a matrix multiplication operation. Okay, now if I want to say like element wise operation, then in this case D equal to A dot multiplication B. So in this case only this element of the A is multiplied by each matrices value of the B. So in this case 1 multiplied by 3 of each the element, that's why the answer is 3 by 3 with the each value is 3. So there is a difference between a simple multiplication and element wise matrix operation. So you can check for the different kind of other operation with the help of element wise operation and without element wise operation, or in the case of element wise operation you just need to put this dot operator. Okay, now we move to the next part. Element wise operation, that is discussed. If a dot is written before an operator, it is associated with an element wise operation. The operation is performed element by element. This is the addition, then this is the element wise addition, this is the subtraction, this is the element wise subtraction. Then similar kind of case for multiplication, right division, left division, power and transfer and conjugate. Then defining a function. So to define a new function, we use the function and function Scilab keyword. Like this is the function y, that is equal to my function of x. This is the header of function, and y is equal to 2 into x. That is the body of the function contain the statement, and there is the and function. That's clear. Okay, so function is equal to y, my function, header of the function, y is equal to 2x, and function. Okay, so that's it. Now if I recall my function 3, then you get the 6 because y is equal to 2 into x. So you actually multiply 3 with 2. So this is the defining a new function with the help of Scilab. This is the header of the function, body of the function, and function. Okay, let's move to the next part, plotting. So that is a different kind of function, inbuilt function used to plot the different function or different element in the Scilab, like plot, surf, contour, pi, his plot, bar, burst, his 3D, polar plot, mat plot, then smooth 2D plot and gray plot. So let's try to plot one figure with the help of Scilab. Clear? CLC. Okay, now say x equal to 0 to 0.05 to 2 pi. So x value is 0 to 2 pi with increment of 0.05. If I put here a semicolon, so this line is executed, but that can be not shown, that will not shown in the Scilab console window. Then say a is equal to sine of x. So sine x is executed. Okay, then just TLC. Okay, so first line is this one, then second line is this one. Just I put here semicolon. Then say plot A is the sine plot. Then if you enter surf any, so this is the surf plot is there. This is the surf plot. Okay. Then say contour. Then contour plot is there. So this is the contour plot. This is, and you can also add title and legend with the help of inbuilt command like legend sine plot. Sine plot. So sine plot is there in the first I once again plot the a function. Okay, so sine plot is there. Okay, now just legend sine plot. Okay, so in this case you can see the sine plot is there with the indication of legend. Similarly, you can use title like sinusoidal signal. So here sinusoidal signal will be printed. Let's check this. First CLC, then title sinusoidal signal. So you can check in the figure that sinusoidal signal is printed. Okay, so that is the use of title legend in the plot. So that is the plotting. We have discussed all the things, and this is the different function that can be used in the plotting like line space, legend, title, x title, all this. So this is the reference of this particular lecture. Hope you enjoy this. Request to share with your friends. If you like it, then press like button, comment. Thank you.